Hello and welcome to this little stand-up talk about some issues in data management. Today I am dealing with digital humanities. So humanities in the past have been a discipline or many disciplines in academia where people just opened a book and read the book and then maybe wrote something about it, with it, or whatever. In the meantime, in the 21st century, of course, we have in our everyday life many digital methods, and that doesn't stop at the humanities. So the humanities now use these digital methods. Of course, we do not write anymore with a pen or pencil on paper, but we write with a computer, with our laptop sitting in the library. And also we use data storage systems. We use in not only the physical archives that are behind the library and where the librarian only goes. We also use digital archives and repositories, not only the bookshelf, next to us. And all these digital methods and strategies, so how do the physical paper books or their content get into the digital repositories? These things I discuss in a broader talk, in a broader lecture. But now I want to focus on a few very important issues that we have to keep in mind when we store data digitally. Of course, like a library, you need an ID card for the library to go there and borrow some books and maybe carry them home, or just to read them there in the reading room. This is one thing, but how to get that into the digital world. So if I just put all my Excel spreadsheets, my data online, then I will run into the problem after a while, after say 10 years or so. After 10 years, everybody throwing their data online and storing, tables on personal websites and a data repository or a YouTube video somewhere else. Then we run into the problem that we have a huge multitude of data somewhere scattered around in the digital space, and nobody will find it. So in um, that is why in 2015, some people derived or developed the so-called FAIR principles for data storage. That was a paper published in a journal that is dedicated to scientific data and data management and so on. And the idea behind that is to make to train users, to train or to tell people who want to contribute data to repositories, or people who just want to share some data of whatever type, research data. I mean, biologists who go to the field and collect any sorts of insects, geophysicists who go to the field and collect any sort of rock type, or astronomers who observe with their telescopes and want to share the images that they have collected in ground-based telescopes as well as in space telescopes. So the idea behind that is, what if a geophysicists want to have access to the data of astrophysicists? And how do we make these data usable by a group of users who are not sort of familiar with this specific type of data, maybe not with this specific field of research. And that is why the FAIR principles sort of make the people sensitive for this sort of problems. The idea behind FAIR is to not just collect the data on your own desktop or in the bookshelf next to you, but also to share it in the internet, yes, to make it somehow findable. You may have seen in websites already that some website making tools allow the user to make the website findable with any sort of search engine, or improve the listing. I mean, all search engines will find it, but this Google search engine is still the most popular, most common search engine. And then some website developers even offer to give you a higher to achieve a higher score, a higher ranking in Google searches. So when the user searches with a Google search engine, your website might be on the top, and if the user searches with another search engine, then it may be not at the top, not listed at the top, but maybe at 10th place or something else. So this findability, that the user who doesn't know what data would be outside there, but just wants to use a specific type of data. So the geophysicist, of course, knows that there are astrophysicists or biologists and that they collect data. But the person, the geophysicist, a specific one, may not know a specific astrophysicist or biologist who contributes the exact data that the geophysicist currently uses. And in order to improve this situation, we want to make the people sensitive to contribute their data in a way that they are really findable. To tag them with the correct words, to think about other people who might have who might search for that data, to make the data findable, then to make them accessible. Of course, it doesn't make sense to have data somewhere around and then the geophysicist doesn't have access to astrophysics data. So ideally, the data would be accessible for everybody, or the group of people who may use them correctly or may want to use them. They need to be interoperable and reusable, which means that people from geoscience or from biology may also be able to understand what the astrophysicist did. Of course, not all the details of how to set up the telescope, but the outcome, the data should be prepared in a way so that standard units are used and not the weird units from astrophysics that nobody outside the field can understand. Or a transformation formula equation should be given, and the data should be described in a proper way so that it is understandable. So if there is no standard procedure to transfer the data from one specific type of unit to another. I mean, for instance, there is a transformation from centimeters to meters. That's not a big deal. But there's not a very common transformation from the unit of magnitudes in astronomy, which describe the brightness, and the usual brightness descriptions with lux or lumen. So if there is no standard transformation equation, then there might be a very good description so that people from the other fields still will be able to reuse this data, which is the data that are uploaded by someone from another field. This is for the FAIR principles. So ideally, if everybody follows the FAIR principle, it would be very easy to exchange data even in a transdisciplinary or multidisciplinary context. And that would be great. So the ideal data distribution would consider and address all these 4 principles. But then we have this accessibility thing so that almost everybody, or maybe really everybody, can access the data. But then there was the issue that there might be data that must not be accessible for everybody. I'm not talking about data from medicine. This is a big deal, of course, or military data or anything like that that is not accessible for everybody. But there's also data where you not at first place would consider it somehow sensitive. For instance, there was a great paper or little article in the Science Journal some month ago. And this paper, I'm quickly trying to find it. And this paper reports, or this little story reports a researcher, or centers a researcher who did some data collection on the island of Hawaii. And this person collected data to study the biodiversity. So he wanted to know, the specific researcher collected some leaves and some and wanted to know the distribution of maybe some sorts of plants or something like that. And then he also needed to have access to some farmland because that was the purpose of his study. But when he had collected all the data and found his research results concerning the specific sort of plants on farm ground on Hawaii, then he noticed that many or all of the farmers are indigenous farmers. And one of the main issues was an investigation to compare the indigenous way of farming that is now reintroduced to that island. I mean, it had vanished throughout the 20th century, and they now want to relearn the traditional way of doing it as their ancestors had done it before the 20th century. Of course, most of them are indigenous, and these people um, were a little bit skeptical about the consequences of them sharing this knowledge. So, or the data for using for getting this knowledge. So the idea here is that if we share all the data, that may concern the consequences of the sharing will be that other people can use it, that the data will be interoperable and reusable, and then we cannot control anymore who uses the data and what people who use the data do with the data. Well, that's part of the deal in a way of the FAIR principles, but there might be some contexts, like the Hawaii case, where the people who want to support this specific study of this specific researcher do not want to share the data with really all people all over the world, or with every researcher from any part of the world that they may not know. So the idea was then to develop another set of standards, the so-called care principles, that allow the people who share the data, to have a little bit more control of what will be done with their data once it will be shared. So having the FAIR principles already set up, some 4 years later, in 2020, there was another paper developed by some researchers from a huge variety of fields, also including astronomy, who do research on indigenous cultures, to put it in the most broad way. Mm. And these so-called care principles make us or want us to consider the collective benefit of the data. So what is the purpose of sharing the data? Why should I do that? Why should the researchers share the data? And why should the people who give the data share them really with the public or with a given well-defined community of researchers? So the benefit for the provider of the data should be clearly defined and addressed. In that case of Hawaii farmers that I just introduced briefly, in that case, the researcher wanted to study the distribution of some plants. And what he then did additionally, in order to make his data more useful for the providers, for the farmers, was not only collecting data about plants, like collecting leaves, but he also collected data about a specific sort of, was it insects or spiders of animal, um, in order, what they would need. That was totally irrelevant for his study of, the distribution of leaves on the farmland, but it gave a lot of benefit, extra benefit to the providers, to the farmers who provide this data, who give him access to the land, and who also will later use the outcome of his study. So the first thing is the definition of the benefit. The second thing is the authority of the provider to control whatever is done with his or her data. So for instance, in the Stellarium project, a planetarium and desktop planetarium software, we once had the case that somebody, a researcher from the United States, had contributed some sets of indigenous constellations used by a specific group in the United States, a native group. And this group then later discovered, or the person who contributed the data, later discovered that some planetariums use this data and display it in the dome, but they also earn money with that. And then the person was not okay with that anymore. They didn't want to share this data anymore because they didn't want other people to earn money with their data, with their indigenous rituals and traditions and so on. So then they withdrew the data set, and that must be possible. It must be possible for a person to have control what is done with the data and if something occurs, then to, delete or at least somehow blend the data, maybe delete it totally, or decide that that only a specific group of people can have access to it. So make it private and give the link only to a few people with whom they want to share the data. So there should be a collective benefit. There should be a benefit for the provider, and the provider should have the authority to control what is done. And yeah, and this also, of course, involves a collective, not only a responsibility by the researcher, but also by platforms who give access, who allow to share the data. Because I mean, we cannot do much. We can, when we develop a platform, a portal, we can only remind the researcher to consider these principles. So then we can sort of only implement a little button saying, yes, I'm sure that I'm allowed to, and here's my permission or something like that. The actual work has to be done in the field, of course. But still, this is also a part of the responsibility of those people who store the data to remind them, as we also have to remind them that they provide their data if they share it under the FAIR principles, that they provide their data for the public, or they should give it a non-commercial only license or something like that. So we have to tell them, because they are not lawyers, they might not know, but we as a portal, as a data storage system, we have to remind them on all these issues and maybe explain to them what it means to share your data, in Wiki Commons, really with a CC0 license, or maybe with a CC BY license. So what does it mean for you, for the person who collected the data? They want to be credited, so they may share it in a CC BY license. But then also companies can use it, and then they have to, the contributor, the provider of the data, may restrict the data even more, may want to have a CC BY non-commercial NC license, and so on and so on. So all these different flavors of CC licenses have to be explained. The user, the contributor, has to accept the fund and fair principles when uploading data to a specific portal or repository or anything. And because of that, because we, for software developers, data storage system developers, we have this responsibility to keep all this in mind before we just build a bookshelf. Yeah, that is it. Thank you very much.